Okay. So all of you can see my screen, right? If you have no problem, then I'll start. Okay. So this session is about, in this lecture, we will be talking about Kirchhoff's law. We will be discussing questions based on Kirchhoff's law. We will be discussing questions based on complex current circuits and capacitance in a resistor or our RC circuit. Okay. So basically, this lecture is all about current circuits and resistances. Okay. And they are very fun to solve. They are not very difficult ones. They look just complex, but they are very easy. Believe me or not, I'll give you some tricks to solve them. That's how I used and how I did in my masters and bachelors. So let's go. So before we start, I want to share some tricks. Here is, yeah. If you're hearing my voice very low, then I can speak louder. So just say if you feel like uncomfortable or if you can't hear me, just tell that. Okay, I'll speak louder. Sometimes people say I speak very slow or very low. Okay, so trick number one, or trick or suggestion number one. Whenever the series circuit, whenever you are given a series circuit, like this, then the total current remains same. So current through each resistor is same, and the total voltage is divided. So V equals to V1 plus V2, and I remains same. Parallel circuit. Total voltage across R1 is equals to voltage across R2 equals to total voltage. So in parallel circuit, voltage across the resistors that are connected in parallel are equal, and that is equals to the total voltage across your battery. Okay, and the total current using Kirchhoff's current law. Okay, this is I1, this is I3. Is this cool? I mean, you guys get it, right? This all is coming from Kirchhoff's law, nothing new. Okay. Okay, so here's a quick quiz kind of thing for you guys. So This is a little variation of the circuit what I previously drawn. Then you have R2, R1, R3. To tell me now, this is a voltage, so would the voltage across R1 and R2 be V or not? So whoever says yes, no, I'm saying total voltage across your battery is giving up EMF or electromotive force equals to the voltage V. Okay, and would the voltage across these two, we know by these laws right here, we know that the voltage remains same, right? Now there is a next another resistor, so I'm asking would the voltage across these points, let me draw in different color, across these points, would that be equal to V or not? Anybody saying yes, that would be equal to V? Okay, so yeah, you all were correct. This can't be equal to V because this is a combination of parallel and series circuit, and as you know, in series circuit, voltage is divided across V1 plus V2. Then you can solve R2 and R1 to equivalent resistance. Then the voltage is shared between VR3 plus VR equivalent. Did you guys get it? Perfect. And the last thing you guys require to solve any question related to direct related to current circuits and resistance and current circuits is this. Would you be able to send the DGD questions before? Okay, so the thing is, I'm logged out of all my um Brightspace account and UOXS account because of multi-factor MFA, and I have sent to the IT help desk that can you please able to help me. Then they said because we are on lockdown, we are short on services. So in a couple of weeks, they'll be solving it. So probably by next week, I'll be able to send you the questions, but I'm unable to access your emails and my own UO access email as well. So that was the problem. So there's something called multi-factor authorization in which you require login from your device as well as computer. It's a two-step process, and my device got reset. Like that, my iPhone got reset. That's why I'm unable to log into any of my accounts. That's why I didn't send you this before. And they said that we'll solve it in a couple of weeks, probably by next week or next week. Yeah, I mean, I can send you by my iPhone, but because I'm logged in there, but it'll be a lot of job to transfer this OneNote to my iPhone and then send it to you. It'll be a lot of work. But let's 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 continue here. Okay, last step you guys need to solve the question is the direction of current. So let's say you have a circuit like this, and you have another battery here. Let's say I'll make it more complex. You have three batteries. Now I give this as 2 volts, 3 volts, and 4 volts. Now in principle, you can choose any direction of current, not like this, sorry. In principle, you can choose any direction of current and solve the circuit. But people always get confused, and when I was doing I was doing such questions, I also got confused in the sense that yes, arbitrarily you can choose and you can apply Kirchhoff's law and go. Let's say you decided to go clockwise, then you have to go clockwise in every loop. But let's make a rule here in the sense that we'll follow the same way for every question. Is that and this will turn out to be correct as well. So I'll tell you, you take the current from the battery having the highest voltage. So you always take the current coming out from there. So I'll give it as I1, then I'll give it as I2, and this I'll give it as I3. So people always say which direction of current to choose. Anyway, if I solve for I2 and I apply Kirchhoff's law correctly, then even if my direction what I chose is wrong, then it will come out as negative. That means I2 is actually going up instead of going down. But a rule of thumb is if you choose it from the highest battery, the battery having the maximum voltage, it 95% it turns out to be good approximation, and in that sense you'll get positive answer always. You won't get negative. Negative just means that the direction what you considered is opposite to the actual current flowing direction. Did you guys get it? I'll use this tip as well today. I'm waiting for your comment. Billy's typing. Yeah, so I think a lot of people get confused, including me as well, that if you have a lot of batteries in the circuit, then it sometimes make it difficult to guess like which is the direction of the current and in which way it makes the circuit most easy to solve and analyze. So if you choose it this way, this will be the easiest. Believe me or not, you can practice on your own. You take the current flowing out from the high. So take current flowing out from the battery with max voltage or higher voltage instead of. Okay. So any questions on these three tips? If not, I'll solve every question using these three tips only. Can we do one where we iterate the loop in reverse to the direction? Yeah, I mean, you can choose to go clockwise or counterclockwise. I'll when we solve the equation, we'll see that. Okay, perfect. So let's start, not waste more time. Let's start with question one. So it's a very easy circuit. It says that calculate the power delivered to the each resistor as shown. You know, power is given by VI, right? Or I square R, correct? Then this circuit can be further solved as you can simplify this circuit. This is R equivalent, or 3 divided by 4, 0.75 ohm, 2 ohm, 4 ohm. 18 volts. The total current can be given as current given as V by R total I total 18 6.75. So you get your I total. Now power delivered can be given as I square R, that means 18.6.75 whole square R 1 slash 2 slash 3. Does this make sense? Any questions? What I did here? So I did find the total resistance and then I divided to get the total current, and that's how I find power through each resistor. And R total is just a series circuit, so is R1 plus R2 plus R3. Okay, I assume it's good for everybody. So that was it for question 1. Is there one with more than one battery attached for power? Yeah, there will be a lot of questions. So I chose some complex ones as well. I chose some difficult ones as well. So don't worry. Here it is. The one you, the one you wanted. Question 2. So yeah, it looks a little complex, right? So let's see. Determine the current in each branch of the circuit. Okay, so time to determine the current in each branch of the circuit. So let's first draw the circuit. We have space. Let's draw the circuit. I'm just simplifying it so that it doesn't look scary. Q, Q4, 12, 4. So what I did is just I added these two in series, these two in series, and these two. I have written the equivalent resistance of these here. 3 plus 1, 4, 5 plus 1, 6. Okay. Now using tip number 3, I said take the current from the battery having the maximum voltage. So I'm gonna do the same. I say I3, I say I1, say I2, right? And I'm gonna traverse counterclockwise for the Kirchhoff's law. Using Kirchhoff's voltage law, I can write in loop 1, let's call it loop 1, let's call this loop 2. So 1, 12 volts minus 4i3 minus 6i2 minus 4 equals to 0. Loop 1, loop 2, loop 2, I can write it as 4 plus 6i2 minus 8 I1 to 0. Anybody has problem with this? You can ask me doubts. How I wrote this. Two equations and two loops. If there's no problem, I'll go ahead. Yeah, Billy's typing. That's why I'm waiting. If we had gone the other way, it would have been minus 12. No, it's okay. It's always equals to 0, so it doesn't matter minus and plus, right? You can always take minus common and that will be the same equation. So if you want to see what's the other way, you multiply this equation by minus. That's the easiest way to solve it. Make sense? Yeah. So that's the easiest way to find the if you traverse it in clockwise direction instead of counterclockwise. You just multiply it with minus, and minus doesn't make any difference because anyway it's equal to 0, so you can always take that common, right? Perfect. Okay, we have another equation using Kirchhoff current law. At any point you guys have any doubt, you can ask me. You can open your mic as well. I've given you the mic rights as well, so you can open your mic and ask me questions there as well. So feel free. If you find anything confusing, feel free to ask me. Okay, and then I have three equations, two unknowns. I solve using substitution, solving using substitution. We get, I've solved it beforehand, so I practiced it before giving you, so that's what I'll get. I assume all of you know how to solve this, like three equation, two unknown, right? If no, I can solve it for you, but I think it's straightforward. You just substitute the value of I3 and eliminate one of them to find the value. If yes, I can move forward. Perfect. Also, see the tip number 3 was to, I want to emphasize that point, was to take the current from the battery having the maximum voltage. That's why you see all the currents are coming out to be positive. That means the direction we considered in solving the Kirchhoff's law is correct. So we guessed it correctly that the direction is right. So that's why it helps always, that tip. Okay, perfect. Find the energy delivered by each battery. So what is energy? And it's also given that the circuit is connected for 2 minutes here. What is energy? Energy is B part. Energy is P delta T. Power into time. What is power is VI into delta T. So for battery number 1, we call this one as 1, this one as 2. So for battery 1, power is given as 12 into 1.31 into 120. Factor 2 as 4 into. Okay, you should be asking a question why I consider this to be negative, right? That's a question, right? Again, as you see, I2 is going in the battery. That means the battery number 2 is being charged by battery number 1. That means the energy delivered by each battery, the battery number 1 is delivering some energy, but battery number 2 is gaining energy. That's why it's negative. Does that make sense? Because your direction of current is going towards the battery. It's opposite to the direction of the current what the battery would give, right? It's just making sense of what physical picture is. So this minus sign just denotes that it's nothing. It's for no other purpose. It's just denoting that the energy, instead of the energy is not being delivered by battery number 2, it's gaining energy. That means it's being charged by battery number 1. Okay, so C is find energy delivered to each resistor. C part energy delivered to each resistor. Let's call them R1, R2, R3 is R1, R2, R3 is I square R1 to delta T. So I1, I2, I3, R1, R2, R3 and delta T. Does this make sense? So you substitute for, if you want to find the energy delivered to the resistor number 1, you say I1 square into R1 into delta T. And delta T is 120 seconds. This is seconds. Okay. Identify the type of energy storage transformation that occurs in the operation of the circuit. So what do you think? What type of energy conversion is going on in the circuit? You guys can get that answer. I mean, so what type of energy your battery stores? It's chemical potential energy. And what's happening in the resistor, that whenever you supply a current to the resistor, then it changes into the heat, right? That means it is increasing its internal energy. So chemical potential energy is being transformed into the internal energy in the circuit, in the resistor. And so chemical potential energy is being transferred to the internal E of resistor. That's one conversion that's been going on in the circuit. And another is chemical PE of battery 1 is being delivered to chemical PE of battery 2. It's being converted to chemical potential energy of battery number 2. Does this make sense for question D? Okay, so part E is total amount of energy transformed into the internal energy. So total amount of energy is transformed is the total energy delivered. The total energy transformed is P1. Sorry. Any questions? If not, I'll move on to the next question. Good. Thank you. Okay. If you don't afraid to ask any type of doubt, no matter how silly it is. Maybe it's silly for some, but no doubt is ever silly. Okay. So it's especially in physics. So ask me anything. So don't keep it inside. Okay. Okay. This one is a little complex. The question, as you can see. Okay. Taking R as 1 kilo ohm and let me draw the circuit. Let me draw two circuits. I'm gonna ask you the question here. It's related to the tip number 3 I gave. So it's actually connected. Okay. Known as R, B, C, C, 2R, 4R, 3R. Okay. So we have to determine the direction and magnitude of current in the horizontal wire between points A and E. So these are the points. So we have to determine the magnitude and the direction of the current. So using tip number 3, can anybody of you please tell me what would be the direction of the current? We'll compute the magnitude, but I can literally guess here what should be the direction of current. Should it be going towards right or should it be going towards left? Because this is the only two possible directions here. Just remember this is the battery with the highest voltage, right? 2 into 250. Okay, one vote for left. Do we have any other vote? So the current goes from positive to negative. So it goes in the negative pole. No, that's point A. Sorry, not Q. So yeah, so Max, you're correct. It will go from A to E. Okay, it will actually go from A to E. Let me tell you why. So you were correct. Perfect. So we'll we'll divide this as this, 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 this. See, I have drawn the currents in all the branches. So the total current goes from here, it goes here, and then it divides here, here, and here. Then it goes back to the circuit, to the battery, to complete the circuit, the closed loop. And because this is the one with the maximum voltage, then I know this should go this way, the current coming up, and that's why I know this should go this way and this should go this way. I can literally guess it. And I'll tell you, it will come out to be correct. I solved it before and the tip always works. So let me solve the simplified circuit for you so that you'll visualize it better. Don't worry, these circuits just need a little bit practice. Once you solve them, once you do some practice, you'll be able to guess as well. These are the easiest and the most fun thing to do in currents and electricity and magnetism. So let's solve them. So this will come out as 1.71 C E T. Let me call this A dash, doesn't matter, I can call it as A 250 volts, 500 volts. Yeah, these are considered parallel, so that was the point. So you see this point and this point, there is between point A and E, there is nothing there, right? No resistor, no capacitance. That means it's just a wire. So you in principle you can make the wire to be infinitesimally small. That means you can make it in theory as small as you want. I made it as a point. I converted it to a point right here. That's how I knew that it's a parallel. So that was a trick as well, but that's how you guess it. If there's nothing in between, that means you can make it as small as you want. So that means A and point A and E actually the same point. We can draw them like that, but to make it easier, I draw them like that so you can visualize it better. Everybody with me, right? Okay, I assume. So also R is given as 1.00 kilo ohm. Now I'm applying Kirchhoff's voltage law to the loop A dash E D C. A dash. Okay, let me go counterclockwise. Counterclockwise. Let me say this is as I2, I1, I3. I can take them as I1, I2, I3. I just solved it this way, so when I was solving the question. So that's how I remember this. So let's do it. Can be written as 500 to I2 plus 1.71 I3. And for the loop A dash, C, B, A, I can write it as going in the same direction, counterclockwise. I can write it as 250 equals to 1.71 R. No, R is given as 1, 3 minus I1. Anybody has any problem here? These two equations, equation number 1 and equation number 2. I call it equation number 1, call it equation number 2. Using Kirchhoff's voltage law. If not, I can move ahead. Okay. Okay. So also another equation is using Kirchhoff's current law is I2 is equals to I1 plus I3. So I substitute them in equation 1, 500 to I1 plus 3.71. Sorry. So and substituting for I3 in equation 1. So that would be 3.71 I2 minus 1.71 I1. Same in equation 2, 1.71 I2 minus 2.71 I1. Find the common factor, and then I1 will come as solving these two equations simultaneously. You'll find it as minus 10 milliampere and I2 as 130 milliampere. Okay, so that means the direction of I1 was opposite. I1 was going like this way instead of going this, right? So I can, if I consider that, I can write it as 10 milliampere. But I'm not writing that, so I solved it like that. So I was just giving you the physical. So it seems like the tip 3 is not working here, is it? At first it looks like, but no, if you look carefully, the direction of I2 is correct. It is coming out to be positive, right? But what's going on with I1? So what's going on with I1 is, yeah, it's just the opposite direction for I1, because this resistance is smaller than this resistance. That's why your direction of current is different. It's a little bit deep what I said right now, but this is why the current is being flowing in the opposite direction, because of the voltage drop across the resistance. Okay, and the direction of I3 is also correct. So I3 is I2 minus I1, that is 130 minus 10, 140 million. But it takes the path that least resistance. So that's how the voltage drop works. So because this is a series and parallel circuit, so you have to balance the total voltage drop. That's why the current is going in this direction. If you, I'm not going into deep in that, but the tip worked. It's giving you the direction of I2, correct? Okay, I2 is going in the direction. It's always emerging out from the battery having the highest voltage. I should have drawn it like that. Okay, okay. So we had to determine the direction and the magnitude of the current in the horizontal wire between A and B, C and E. So what is the, just a minute. So what is the potential drop? What is the potential drop between point C and A? Okay, let me draw it. VC minus VA dash can be written as IR. That is I2 minus I1 into R. 140 into 1.71. Right now, okay, this is the total voltage we have. Now we know in the circuit here, here, here. Okay, we did find the voltage drop across point C and point A dash. That should be the same voltage drop across point. So let me type it what I'm saying. VCA should be equals to VCA dash. Does that make sense? Yeah, I1 is going to the opposite direction. So that's why I1 is negative. Okay, I'm just sticking to the convention. So it resolves itself. Exactly. So if I'm not making it more confusing to you guys by changing in the middle of the question. I'm just doing what I assumed before, and I'm taking the correct negative signs at the correct places. Okay, so that it resolves itself. So now I'm making a comment here that VCA is equals to VCA dash. This is based on my previous explanation when I said that when there is no resistance and capacitance in the circuit in between points, then you can assume them to be the same points. So VCA is VCA dash. Okay. Okay. So now the current through the arm CA, ICA is VCA divided by R 4R, that is 140 into 1.71 divided by 4. Okay, that solves your equation, and so you get the total current here, ICA, and your I, let's say the current going through is I, on applying to find the magnitude, to find magnitude in the branch A to E, right? Find the magnitude in the branch A to E. I'm applying K current law at junction A in figure 1. In fig 1. Then I4 is equals to I1 plus I. I4 is ICA minus I1 equals to I. Does this make sense? Okay, I'll give you like a minute or so, so you guys can go through it once again and ask me any questions if there is. Okay. If everything is good, I'll go ahead. Okay, I'll move ahead. I hope it made sense. Okay, let's move on to question number 20. In the circuit, the current I1 is 3 amperes and the value for epsilon for the ideal battery in R. So the ideal battery means there is no internal resistance. And R are not. What are the currents I2? So let me draw the circuit again. The circuit can be drawn as, we have been given directions of the current, so we don't have to assume. Sweet. Let me draw the correction by the red color. Uh, the directions have been given to us in the question itself. What are the currents I2? We have to find the magnitude of I2, and I1 is given as 3 amperes. Okay, this is 6 ohms. So let me call this point A, point B, C, D. In loop A, B, C, D, A. Let me go counterclockwise. Sorry, clockwise. Doesn't matter. So 24 minus 18 plus 3 I2 is to 0. That means I2 is minus 2. That means the direction is opposite to what the question gave us. Question is giving that between point A to B, they gave us that the direction of current is this, but it is actually this, opposite to what they gave us. So that's the answer for part A. Part B. What is I3? Let's solve for I3 now. So using Kirchhoff's current law, I1 plus I2 is equals to I3. Using this, using the direction of the currents they gave us, okay, and then I can write it as I1 as, sorry, I3 as I1 no, my bad. Yeah, that's correct. Okay, so I can write it as I3 as I1 minus plus I2. I've written that already, just need to substitute the numbers. So 3 minus 2, 1 ampere. So any questions here? I'm using this equation based on what they have given us. Because I solved it, because I solved the question using the direction they gave us. Okay, I'm not changing my direction of I2 based on the answer, but I know physically it's going from point B to A. So when you have to write the answer, you say that I2 is minus 2 ampere. That means that the current is flowing from B to A instead of A to B as given in the question. and you will get 4 marks. Okay, so point C. Point C is, can you find the values of voltage in R? If so, their values, find their values. If not, explain. So there are two unknowns, R and E. So R is not known, and E. So the question is asking, can we find that values? If yes, we have to find it. If not, we have to explain it. So how many of you, it's again a voting question, thinks that we can find the value of epsilon in R, and how many of you think we cannot? Just whoever in favor say yes or no. We can't. Okay. One said we can't. Yeah, you can't. Okay. Perfect. You guys are correct. We can't. Can any one of you tell me why we cannot do that? Because in just that cycle alone, you have two variables. You won't be able to make up a loop equation. Yeah, so it's kind of, the answer is kind of like that. Partially yes. So in the two equations we did in loop 1 and using Kirchhoff's current law, we don't have any unknowns there. So there were no variables. So, and the only loop left is this one. Let's say loop number 2, this one. And then we will have one equation and two unknowns. I'm writing like that. One equation and two unknowns. That means we cannot solve it. We cannot solve it. So does it make sense? Okay. Okay, let's move on to the easiest question of today. Find the equivalent resistance between point A and B. So let me solve it like this. Okay. You have to find the total resistance between point that, or equivalent resistance between point A and point B. You just keep solving the circuit, simplify it. Okay. So keep simplifying until you get the single resistor. Any questions? How I solved it? So starting on that, these two are in series. Next step, these are in parallel. Next step, all of them are in series. Okay, I hope every one of you get it. Okay, perfect. Thank you. Let me move to slightly different question. Okay, calculate the potential difference. Now we are talking about potential difference between point A and point B. Let me draw the circuit for you guys and ask you the question again. You'll have another voting question. If you guys don't like these voting scenarios, I can skip them, but I think people like it. That's why I keep asking or keep putting questions which have like which people say yes or no and stuff like that. But if you guys don't like it, I can skip them as well. It's just your choice. Okay. I think it just gives you the better understanding of you thinking instead of me solving questions, just like a solution manual. So, okay, so the calculate the potential difference between point A and B. The point A and B is given here. So the first thing to notice in the circuit that point A and B are open circuit. What happens in open circuit? I'll ask you. So identify which point is at higher potential. That is the second part of the question. First part is to find VAB, right? Okay. Now, tell me what happens when the circuit is open. Would there be any current in this branch and in this branch? How many of you think there will be current in this branch? And how many of you think there will be no current in this branch? In these two branches, branches A and branches B. From point O, E to point. So, will there be a current in OA and EB branches? Yes, perfect. Perfect. So these are like open switches. Uh, so whenever the circuit is open, that means the resistance is infinite. That means you cannot have any current there. Infinite resistance means no current flowing. Something is resisting infinitely. So we have only one loop. Let's find the current. So 12 volts in loop 1 minus 2I1, let's say I minus 4I equals to 0. I as 2 amperes. I flows like this. Okay. Now, so part A of the question is to find the resistance potential difference between point A and B. So we have to find VBA. So that means let me assume a battery here Just assuming it, okay? Just to apply Kirchhoff's current law or Kirchhoff's voltage law, I'm assuming it's a closed circuit, but it is not. Just to give you visualization, okay? I can go counterclockwise or clockwise, doesn't matter. Let me go counterclockwise because, or clockwise, so it went like that. So what is the equation? Is VBA, we have to find, and can use imaginary loop, 10 into 0 plus 4 into y1 minus 4 is equals to that also answers question part B. That which VA is at higher potential. Any question here? Okay, I don't need, I didn't, so there was no need to compute this equation instead of it. They are asking in the question, but just if they ask, let's say, for example, if they ask just which point is at the higher potential, I don't need to do this. How I can find it is that I know the current is flowing from point O to E. That means potential at this point is always higher at this point. That means potential at A is always higher than B. Does it make sense? Because they asked me calculate the potential difference between point A and B, that's why I calculated. Okay, perfect. I can move on to the next question if you guys have no doubts based on this one. I hope I'm covering all the varieties in the question so that your doubts based on Kirchhoff's law are more or less addressed here. Because one of you sent me an email yesterday saying that you guys have some problem solving Kirchhoff's law, so I took all the possible variations of the circuit at your level. Is it okay? So this one is the last question, and this is Wheatstone bridge circuit. Profs loves to ask this type of question in exams, especially the Wheatstone one. So that's why I'm picking that. Okay, seems little challenging or little complex at starting, but it won't be. Believe me or not, it is very easy question. Looks little challenging though at the beginning, but once you simplify it, it will be okay. I've drawn the circuit diagram. 3 2 80 R 3 microfarads. Okay, determine the equilibrium charge on the capacitor in the circuit as a function of R. So we have to find the equilibrium charge. That means part A. Let me solve part A. To find equilibrium charge. So at equilibrium, there won't be any current in the branch AB. Current branch A to B. That means like an open circuit. Okay, I have written a statement here. I hope you all agree. At equilibrium, the capacitor is fully charged. It behaves like an open circuit. There's no current flowing in branch A and B, branch AB. I hope it makes sense. If it is, I'll move ahead. Okay, let me find the voltage at A. You know what is charge? So in the question they asked me charge. So charge is CV or C delta V, VAB. That means C VA minus VB. So I just need to find VAB and VB, right? So let me just write that. What is VA? Total current in the circuit is total voltage. How can I find VA? Is let me tell you the short part. VA here and VB here. The voltage at VA means the voltage across the resistor with 3 ohm value, and the voltage across B means the resistor with voltage 2. Okay, so VA can be written as V minus V80. VB can be written as V minus VR. If you guys agree, no, capacitor doesn't act as a wire. It acts as an open circuit. So that means that's how I have written these equations. That means your circuit essentially is like this. At equilibrium, when the capacitor is fully charged. Okay, so you guys get it how I wrote these equation? It's a total V, so voltage will be shared V1 plus V2, and if I have to find V1, I subtract V minus V2, and then that's how I get V2 V1. So I can find VA and VB. Okay, if it's okay, then I'll move ahead. So let me substitute the values for VA. That is total is 5 minus 3 into 5 by 83. Okay, how did I find this? How did I find this? Is what is V is IR, right? What is R is V divided by R total 2. Just made a mistake. Sorry. R3 normally call it just 3. If it's okay, then so this is the current in this branch, and because the voltage drop across this point A means the voltage drop due at resistance 80 and due to the resistance 3 ohm. Yes, I think how I drawn it makes it a little confusing. Let me make it clear. So if I have to find the potential at point A and point B, in principle, point A is here and point B is here. Let me see if it makes sense here. If I have to point at point B, then I have to find the potential drop at across this resistor that let's name it R1 and this R2. Then I have to find, if I have to find the potential drop at point B, then I have to find, it can be infinitesimally small. That means I have to find the potential drop across R1 due to R2. I mean, it will be shared between R1 and R2 total V. That's how I will get that. So before, when I drawn this across this, that means the part of the potential will be shared by these two resistors. Does it make sense to you guys? How I get this equation? So our total is 80 plus 3, 80 plus 3, 83. V is 5 given in the equation, the voltage drop across the battery, and 3 is the resistance with 3 ohm. I can name them as well. Let's call them R1, R2, R3. and R. Okay, let's remove this one so that it doesn't make much confusion. Okay, if you guys get it, then we can write same for VB. We can write same for VB 5 minus R, or sorry, 2 into 5 by 2 plus R. Does it make sense? For VB, if it's okay, then now just apply equation 1, Q at equilibrium, C delta B at equilibrium. C is given as 3 microfarad, 3 into VA minus VB, that is 3 into 5 minus 3, or 5 1 minus 3 by 83 minus 5 1 minus 2 by 2 plus R. That will be 15 and right, if I take 5 common, 2 by 2 plus R minus 3 by 83. That's your total charge at equilibrium. I was just solving the equation, like simplifying it. If it's okay, I can move to the part B of the question. I'm waiting for your questions. If no question, I'll move to the part B. Okay. Part B, evaluate the charge when R is, so just substitute the value of R to 10 ohms. You'll get the charge. You'll get the charge. Okay. I didn't do when I was solving it, so you can do it. You just have to substitute the value of R in equation 2. Okay. Equation 2. Okay. Can the charge on the capacitor be 0? If so, for what value of R? Yes, capacitor charge on capacitor can be 0 if Q equals to 0. In equation 2, we get 3 by 83, 2 by 2 plus R, 6 plus 3R, 166, or R is equals to 160 divided by 3. That's okay. Sorry, isn't it 15 into 10 to, yeah, it's 15 into 10 to the power minus 6, but yeah, I mean, yeah, you're correct. I'm not writing that in terms, but mm, you can take care of the, right? I mean, dimensions. So whenever you write it, you're correct. It is that. Yeah, it's microfarad. So yeah, yeah, it was microfarads, but yeah, in principle you have to write it 10 to the power minus 6 into, but it's common, so I can just keep it outside, right? I mean, the multiplication is outside the bracket, so I can keep it outside, so I don't have to worry about the units. Yes, you're right. Don't do that mistake in exam. That's my bad. I should have mentioned it. Okay, just a sec. Mm-hmm. And what else we have? So this will be around 53.3, if I'm not wrong. And D part, what is the maximum possible magnitude of the charge on the capacitor? For what values of R is it achieved? So maximum possible charge, D part, for max charge, substituting R equals to 0, equation 2. So in this equation, I'm just substituting R as 0, then I can find maximum charge, QE max, 15 into 10 to the power minus 6, 2 by, or I can write it as microcoulombs. Actually, I don't have to write in coulombs. I can write in the end microcoulombs. Does that makes more sense, right? I mean, it's easier. I don't have to carry 10 to the power minus 6 in my calculation. You guys agree? So that will be 2 by 2 will be 1 minus 3 by 83. So 15 3 microcoulomb. This microcoulomb is because the capacitance is microfarads. So I converted that microfarads to microcoulomb. Okay, let's move on to question number, last part of the last question. Is it experimentally meaningful to take R as infinity? Explain your answer. If so, what? So what is the physical meaning of R equals to infinity? I want you guys to answer that. I covered that in previous questions as well, and I think in the last question. So what is the meaning if R is infinity in the circuit? Yes, that means current is 0. Yes, that means the circuit is closed or open. Perfect. So yes, experimentally we can have R equals to infinity. That means you have to write in the exam that yes, we can have when circuit is open between the points having r, then r tends to infinity. Okay, and you can find QE when r tends to infinity. R tends to infinity. 2 by 2 plus r. This is a negative sign. So minus 3 by 83. That means this term goes to 0. We have minus 45 by 83. This is around 0.542 microfarad, microcoulomb. It's is it okay? You guys get it? Okay, perfect. So let me conclude today's session. We solved like 7 questions today. It was a lot. We covered Kirchhoff's current law, circuit diagrams. We covered various configurations of circuit diagrams today, and we solved all the equations based on these 3 tips. That the series, if the series circuit is given, then the voltage is the total voltage drop across 2. You add them, and the current remains same in the series circuit, and in the parallel circuit the voltage drop remains same and the current is the summation of the current in both the branches or in several branches. And we consider the direction of the current emerging from the battery having the maximum voltage drop or maximum voltage. In that way, most of the time, 95% of the time, you will correctly guess the direction of the current, as you saw today in several questions. That's what we did. If you guys have any question, you go ahead. Any question you can ask me. Was also just I want to ask. Let me stop the